I'm Aritra Mukherjee. Let's start this session. We'll have a very fun time. Akshay Goel just gave an amazing speech about editor tools. You guys learned how to make a simple one, and this session is about a behavioral tool that I have designed using Unity, and all of you are programmers, right? I've been following from the previous sessions, and how many of you have ever tried designing an FPS, a first-person shooter, or any kind of shooter, or any kind of games that like involves projectile physics? So maybe this will help you get a new idea to it, or maybe this will, like the ones who are just getting started, the ones who are like intermediate. Between beginner and intermediate, even they will get a direction to how to approach this kind of problems, how to like design bullet physics, jump mechanics. Okay, the tool that I have designed like makes FPS designing, makes bullet trajectory designing, jump designing, any kind of ramps, like you see these cars flying in the Mario Kart, you have ramps. So it speeds up the design process, and as Akshay said in his previous speech, that it is about connecting the designers with the programmers, right? So tools would help, maintaining a communication, maintaining a swift communication between programmers and designers. Let me tell you about myself and my own company, Slylad Interactive. So Slylad is a cool company with, like great values, and we are 4 people. I am the only programmer, and I have a quality assurance guy who is also doing the art in this indie studio. And the only thing I remember about IGDC is, like coming 2 years back as an audience and stepping 2 years after as a speaker. Our studio has been selected in the Indie Games Accelerator event. I have made a lot of cool projects with Unity. I have been working with Unity from 4.6. You can, I can actually ask you to go and check some of my cool projects. In YouTube, you can search my name, Aritra Mukherjee, portfolio in the Slylad Interactive YouTube channel, and you will find some cool projects that I've attempted with Unity. Okay, so let's start. So as it said, it's a complex projectile tool in Unity for action games. So this is our tool, and we'll just see an application of it. Okay, so the need of designing this projectile tool was to ease up the design process for ballistic projectiles like bullets, any kind of cannons. It was targeted about receiving detailed trajectory information, so that as a designer can change the values at runtime, at any time, to like have more flexibility while designing, to have more control of what is going to happen. Like in a cinematic situation, when a car is flying off a ramp, you cannot like take a risk by like trusting the physics system or trusting some custom physics that you wrote for that car to jump off. You don't know that if it is going to maintain a like similar level of performance, and it is going to land in a particular spot. With this projectile system, you can like control everything. You have all the details about the path. You can change it in runtime, and this is not, a lot of people were saying this is an array-based program that you have written, but it is not array-based. It is completely like based on runtime physics calculation. We'll see how. So this would target jumps and ramps, and this solution also works for dealing 3 kinds of velocities: rigid body, the non-rigid body velocity in Unity. You can use this system with the rigid body physics, non-rigid body physics, as well as like character controllers, any kind of custom colliders as well. So the video that is playing in the background shows that how easy it is for us to design such kind of jumps, double jumps, and we can see with the editor tools that there's a prediction system that is constantly running and it is telling that where we are going to land with the character. Maybe if it is a bullet, this, I'll just pause this video for a moment. This is the thing. This prediction system runs all the time long, and you can adjust these values, adjust the range, adjust the launch angle, adjust the number of details you want to display. Like if you are throwing a grenade and you want to show the path, it is very easy. It's just a drag and drop mechanism. Just your designer, as a programmer, you just write this tool and you send it to your designer. He just plays around with a few values and he's done. Okay, so same with the application of this little character Durga here. She jumps, and I just update the angles, the launch angle while running around, and press PES to simulate through that trajectory while jumping. And you can interrupt the simulation while jumping along that trajectory. You can interrupt the simulation and launch another jump from that simulation point, so to execute another double jumps or any number of jumps from that point. So this is one use case. I'll just move to the next slide. Projectiles. This is a very important solution. This is a very important requisite if you are designing games. Like projectile physics is required almost everywhere. Linear ballistics and projectile ballistics are something that you are going to deal every time when you are designing action games. As I told you, it may be that you are using jumps, boosts, ramps, bullets, cannons, path prediction, accurate simulation of objects, any kind of bias, like maybe you want to break the available physics system of Unity. So you can design your own system for that. Last one is flexibility. Flexibility is the most important part. We will see at the end of this thing how flexible it is for us to actually write a shooter or design a shooter game with this tool, with the script. Let's understand the bullet trajectory first. A lot of us design action games without knowing how a bullet trajectory appears. I just read a blog maybe 2 days ago from the Call of Duty Modern Warfare developers, and they just brought in actual retired Navy SEAL personals to communicate with the developers about how the gun mechanics feel, how the bullet trajectory works, how things what it is like to fire an actual gun. So a lot of game programmers here or developers here may not consider these important facts, and that actually reduces the gameplay experience, output gameplay experience. So we'll just understand what bullet trajectory looks like and why it was so important for us to develop a flexible system. So a bullet trajectory, bullet is not shot linearly. You see, to match the target, the bullet muzzle, the gun muzzle has to be aimed upwards. The bullet has to fly upwards, travel a projectile path, and then shoot on the target. And the effect of factors like gravity and linear fall off, whatever you would call that, keep increasing as the farther the bullet goes from the gun, the spawn point, the gun firing point, the more the gravity acts, and the curvature, path curvature increases. So the main thing here while designing a bullet trajectory is to maintain, two things are important: maintaining an elevation and the projectile path. About the projectile path, we need this important metrics like this launch angle, aim correction. Aim correction is nothing but the aim elevation, and aim elevation can be easily understood by this, watching this, I'll just play this again. Aim correction is nothing but the launch angle. So these are the factors that are affecting the bullet trajectory, and we will deal with a few of them. So this is the aim correction. If you draw a straight line from here, from the gun muzzle point, and the angle, the launch angle here is the aim correction or the elevation value that we will be using to draw a trajectory path from the spawn point of the bullet, and then adjust the path so that it meets our requirement, like a preferred range or something, whatever you would like to call that. Another is mass fraction. Mass fraction is the amount of gravity you want to, apply throughout the trajectory. This would be a factor. This would be a very important factor for the curvature of the path. Linear fall off is for fine tuning the bullet trajectory. When you have just fired the gun and the bullet is traveling for the first few seconds, it has a lot of thrust to it. So gravity is not, changing its state a lot. But after it has traveled a lot, then gravity becomes more powerful than its, available momentum that is, affecting the bullet velocity. So the path would actually fall suddenly down rather than going straight. Another is the simulation speed. The simulation speed is nothing but the time scale of simulation, and it would just it's a cool feature you can use to slow down the simulation of the projectile trajectory. Maybe some car cinematic, you want the environment to be acting fast, like maybe it is acting as part of the unity time scale, and you want the simulation of the projectile to be slow. The car is landing slowly, the car is in slow motion, but the environment is acting fast. You can attempt such kind of problems to this. Spread is nothing but the the radius on the wall you are going to hit, the radius in which the bullets are going to be spread in the wall you are going to hit. That is important for introducing probability. Maybe you shoot and it misses, the bullet misses, and so that you have a factor, it's not like hard coding the thing. That is it. So ease of design. I showed you what a bullet trajectory is from a video I took from YouTube, but this video is recorded from my own Unity editor after I have made the tool and executed it. Let's play it. So this is what it looks like in the editor. You have these handles like power, correction, error, fall off, effective mass, simulation speed, and spread. Let's see how after writing this tool, when you change these values, what happens, what kind of results we get. And you can literally see how easy it is for designers once they have this tool with them. I have obviously reduced the bullet speed so that you can see the bullet speed can be increased to at any value you want, and the collision won't be a problem because it's on you. If you are using a rigid body, you can trust on the continuous dynamic filter, and the bullets won't pass through the wall, and it won't be like a quantum bullet thing passing through the wall. And maybe you can also write your own collision system using a grid of raycasts. That is more beneficial to me. I feel that is more beneficial. With this frustum, you saw that I was just raising the frustum, that was increasing the spread. I can change the curvature of the path. I can change the range. So these are a few functions I have. So ease of design. You can design settings for multiple long-range weapon types, and you can save these settings in a scriptable object. You can scriptable objects are a part of editor scripting, you may call it. It is just that the values you store at runtime would be saved as a prefab. So you can write your own scriptable objects to save various settings for gun types. Maybe when you are designing a pump action shotgun, you would increase the spread and reduce the range of the gun, increase the curvature because the bullets are usually heavy in pump action shotguns. When you are designing a handgun, you would increase the range, reduce the path curvature, and the damage would be less. So this kind of settings you can design for individual guns and store it in a scriptable object. Have full control on how your shooter game will behave. If you trust on the physics system, you don't know what it is going to do. Maybe you are designing a virtual reality game, and maybe due to some kind of performance error, or some kind of coding mechanism you forgot to enforce, it could be a miss. The bullet could, it would be very difficult for you to debug if the game situation goes out of hand. Maybe the player is doing something, maybe the testers are doing something, and a very abnormal thing is coming up. You won't be able to trace what is causing it. So for that reason, it is very important for us developers to consider these things, to have control on our design, so we know that what our code is going to do. That is much like a magician. He knows what his magic is capable of. Okay. States for muzzle flash, bullet marks, and additional behavior you want to include when the bullet is in mid-air. So the tool I have written, the scripts will, has callback interfaces. There are 3 callbacks. One is on launch of the trajectory, on update of the trajectory when the projectile is traveling through the trajectory, and when it is coming to an end. Now, there's a fun thing. You can decide when to end this trajectory. Maybe there are 2 ways you can end the simulation. Once it comes to a fixed path, once it has traveled a fixed path, it can end the simulation. And the second condition is if it collides with something. So you can select this kind of callback systems. Projectile maths. You can take a picture, or maybe just note down if you are going designing. A lot of you have designed projectile maths beforehand. So those who have already designed, you may have better approaches to this, but I think this is much better for my use cases, because I'll be going back to Unity and showing gun mechanics I did. This is just mathematics. And there's one thing about the system that I've written. It's about the calculation of the launch angle. It should always be calculated as the signed angle between the aim forward and stance forward. Stance forward and aim forward, you need to understand. Aim forward is the direction where your gun is aiming, and stance forward is the direction you are looking at. So an armored person has 2 directions while we are considering this shooting mechanics. One is the aim direction, the gun direction he is pointing at, and one is the direction he is looking at straight, which is usually parallel to the ground. Declare variables, not var. And these are a few variables that are very important to this trajectory class that I have written. We'll see it in Unity just after these few slides, 2-3 slides left. Space would determine whether you want the simulation. Why I have listed these variables up here, it is because when you go back home, the ones who are designing projectile physics can go back home and actually check if they are missing on something or not. This would I feel this is a great approach to solving problems. Collision mode, using ray casts to predict the collision of the trajectory. You're shooting a bullet, you don't know where it is going to land up. How do you trace the collision? What's the mode of collision detection when you are drawing the trajectory? You are throwing a grenade. In PUBG, you throw a grenade, you see that the red line, the red curvature, ends at the wall. It doesn't go beyond the wall. It ends at the wall and draws a big point there. So what is the detection mechanism we are going to use? Is it going to be through raycasts, through a chain of raycasts, or through a chain of overlap spheres placed at a certain distance from each other. And snap is how you are going to end the simulation, how you are going to decide when to call when the on-path end function is called. Is it called when the projectile collides with something, or if it comes to an end, or if it comes to a preferred path end? Fall off is for tuning. Fall off is not an important factor. Effective mass is for controlling the curvature of the projectile path. Resolution, the number of objects you want to display, the number of segments through which you want to draw a line. The more number of segments you have, the smoother the line is going to appear, the smoother the curvature is going to appear, but it would have some performance cost, because if the collision is turned on, the more number of objects in the path you have to display, the more number of raycasts, chain raycasts you have to do. So it has some performance overhead. Display objects is an array. You can assign it with something to display the objects along this trajectory. And layer is for performance balancing, so that you can decide which layer to hit, so that you can design friendly fires, or you know which collider to hit, which one to not, which ones on collision would perform the callback interfaces. So layers would do that. We'll see these methods within the trajectory class that are doing everything that we see in this video. One is the draw trajectory function. It is taking in all these arguments. All of you might be considering why I didn't pass an object within this argument thing, but I have actually written this so that you can understand the important variables that are necessary with the designing. So draw trajectory takes the initial velocity direction. We have the simulate function, we have the display function, we have the gizmos draw function. This is for the editor visualization. And the last one is the most important one, is the interrupt simulation one. So let's see what it looks in the editor. Just few lines of code, and you have to, once you have designed this tool, you just need to write a few lines of code for solving any kind of ramp related problems, projectile physics related problems, bullet mechanics, and everything. Just two functions are important: draw trajectory and simulate. And this is doing everything for you. Done. And what this thing is doing, see, you can predict where your bullet is going to land. You can design the bullet trajectory yourself by just, assigning a few values. And this is totally performant and feels great while playing. You see, it is predicting the path. You can see the lines. You can see the bullet fall off. I'll just maximize it and switch off the gizmos so that you can actually see the bullet perform. See, right click. So it feels cool. See, the bullets are performing, the callbacks are working, and you can check if it is following the prediction or not. It looks like this. When you shoot, it goes like that. It follows the trajectory. And this is what the code looks like. This is a script that you attach to the gun game object. You see, handgun. This is the, can you see it? Can everyone see the settings? Can you see the individual settings of the gun, the values that are there? So we have this is how easy it makes for you once you have written this kind of a tool for designing, action games or FPS, third-person shooters, any kind of shooter games. So this is just to motivate you to design well, because with all the physics engine in hand and everything given, you may miss the design points, may miss the game design basics as developers, which you shouldn't. And I'll also give an exercise at the end of this session. And this is the trajectory class that is doing it all. You see the space, mode, snap, fall off, resolution, simulation speed. I'll just play it and change the individual settings to see what kind of changes appear. Whether you want collision to, whether you want to check collision, whether you want any collision check on your trajectory. If you switch this boolean off, you see the complete trajectory. If I switch this on, it hits the wall and snaps it. Okay, so now whether I want to increase the bullet spread, I can increase the frustum, and I can increase the correction. This is nothing but the elevation that I'm putting. So when I fire, there's a, you see the elevation is high. The bullet goes up and turns. So that is how you change the correction values. So how does this class look? How does this handgun script look within the within Unity, within the Visual C#? I think most of the ones who ever started designing shooter games used raycasts to shoot bullets, right? You'll just aim and use raycasts to shoot bullets, but you want complexities. You want, like in PUBG, when you are shooting the VSS 9mm, that is a great thing to observe. When you're shooting the VSS 9mm, you can design one with the available Unity particle system, but Unity particle system won't be, able to predict the trajectory. You won't have the designer know where the bullet is going to land. So that is why we needed an interface to visualize this. So that's just few lines of code I've written. Once I have introduced the physics tools library. It is nothing, it is just providing this trajectory class that I have, kept as an instance here. I have instanced it here, and I am calculating the launch angle, which is nothing but the angle of aim and stance, and I'm calculating it in the update, and in the fixed update I'm drawing this trajectory. If you don't want to draw this trajectory good enough, you can say performance. In the fire part, I'm just instantiating these bullets, and these bullets, all of these bullets have a projectile component attached to them, which is taking this trajectory argument, which is taking this trajectory object as an argument, and based on those paths, it is calculating the frame velocity. It is like once you have provided an initial force and launch angle, it would calculate the velocity per frame and would calculate the direction of motion by subtracting from the velocity of the previous frame. So that is how you get the direction of motion, and with this direction of motion you can put this direction of motion in your character controller move function, in the rigid body force function, or rigid body, you can apply this as the rigid body velocity. Also, once you have the frame velocity, you can have the position of the projectile per frame. So if you are not using any kind of collision systems, inbuilt collision systems in Unity, like maybe avoiding rigid body or character controllers, you can just assign that, assign the position of that object with the frame velocity. So it would just simulate the path. The projectile class looks like this. I've put this namespace so that you can just to avoid naming mishaps. This is dead simple coding. This is dead simple coding because I'll be giving a task, I'll be giving a simple homework that you can go back home and try. This code is dead simple coding, and it is not following any kind of design conventions, any kind of design frameworks like the common patterns and the state machine patterns. I'll be giving you a homework on that. So this trajectory class has this interface, the onPath started, onPath update, onPath end. You can take a screenshot, and this would help you design later on when you're writing your own projectile class. You can actually take help from this thing. So you can design this interface. All these variables are there. Here's the main calculation part that is more important. Is the whole text visible? Because you would be able to zoom in once you take the picture. 70% fits it all. So this draw trajectory calculation is more important. This is very simple. It is just taking the initial velocity, the launch angle, and calculating the requisites from the available projectile equations that I showed in the slides beforehand. And I'm getting two things from here. One is the frame velocity, one is the frame position, and another is the frame velocity. Frame velocity gives you the direction of the projectile per frame, and frame position gives you the position of the projectile per frame. So you can now put this direction or the frame velocity in any kind of rigid body functions, character controller functions to you can use that direction in character controllers to produce that jump, to simulate the jump, rigid body for bullets. And here's the simulate function. Simulate function is only required if you're not using any kind of inbuilt functions provided by Unity, like the rigid body move, character controller move. If you're not doing it from there, you can do it from here. So that is it. And in the presentation, I'll just go back once. I'll just show you the best case. We have seen how the prospective bullet appears. If you want to see it once again, you can check. This tool is totally ready for jumps now. We are working on the bullets. We are trying to increase the performance, and we have a plan to release this on Asset Store after doing some of the editor tools coding. Like Akshay showed, you can introduce editor tools coding to enhance, make it easier for designers. And about the exercise part, you can go back home, you can remove all this dirty coding and study some of the important requisites. Like how many of you have ever coded in C# following the conventions in Unity? Do you follow the design patterns? Only very few. This is what surprises me. Once you have hand-on, stuff like Unity, it is very easier for you to get carried away from actual programming concepts. So I'll advise you to go back home and consider this further reads. Study about Unity 3D design pattern states, C# conventions. These are very important for programmers who are not following the bad practices right now. Editor tools and scriptable objects, and 10 common mistakes in C# programming from TopTal. Just go back. Here are some key performance factors you can consider about the the tool we have written. So when you go back home, if you can find a good solution, you can ping me up. I'm available online anytime. Aritra, go and fix this thing. I have found a solution for it. I'm trying to keep this thing open source. I may either put it for free on Asset Store or on GitHub. Anything would do. The path resolution, the collision mode, whether you are selecting raycasts or overlap spheres. Did you see that we were actually drawing some white spheres along the path? If you select the collision mode to be overlap spheres, all of those individual spheres act as overlap spheres, which would decide, the collision states. But if you are using raycasts, it would draw a chain of raycasts along that point. It has individual performance factors, and it is affected by the path resolution. Third is object pooling, which is very important. When you're designing a fight scene, it is very important for you to actually have control of the number of bullets you are spawning. It cannot be infinite. You cannot just go on spawning more and more bullets, you're just shooting, and you just cannot go, and it would have a huge performance overhead. So you should learn about object pooling, the maximum number of bullets you are going to spawn, and there's another thing that is not written here I would suggest. It's the custom culling techniques. You can go and check the culling API of Unity using the culling API of Unity, because most of you are programmers here, and I think not beginners. So you can just go and check the culling API of Unity. So with that, you can check the state of an object, whether it is out of the screen, in the screen, if it is closer to some object, and decide what happens to that object based on such parameters that would help you, optimize your game. Last is collision layers. Design your layers very, like in the second talk about art, we saw that how important for us it is to, have controls on layers when we are designing lights. Similar it is for this kind of tools. It is important for you to give a check about the collision layers, so that you don't go on shooting stuff that you don't require to. That would just raise the callbacks, and the function stack would go on increasing and have performance overhead. Tip: if your code works, don't change it. And yeah, thank you, and thank you so much. This kind of a talk was very, attended at the GDC San Francisco in 2017. You should go back and read that about linear ballistics and projectile ballistics. That would even give you a deeper look into designing of projectiles. Because not everyone is considering this kind of complexities when, designing shooter games. This would give you more control. This would help your designers communicate with your team.